Hi again, everybody. Welcome back. We're getting towards the end of section 2.4. I just have a couple of things to finish first. Remember, please, that section 2.4 is largely about two things. One is zonation, which is fairly straightforward, and the other one is succession. One thing that we need to cover, I'll show you the syllabus in a second, is the changes that happen as you go from the start of succession to the end of succession. And that doesn't matter if it's primary succession or secondary succession. Above my head here, you can see the main things. So as you go from the start to the end of succession towards the climax community, first of all, the amount of organic matter, or we could say soil, increases. The availability of nutrients increases. The ability to conserve those nutrients or to cycle those nutrients or recycle the nutrients goes from bad to good. The amount of detritus or dead material obviously increases, and that's part of increasing the amount of soil. The amount of niches increases as we move towards a climax community. The size of individual organisms increases. Life cycles become more complex. You know this from one of the previous videos that we go from R strategists to K strategists. Biodiversity, I should have said there, increases. Food webs become stable. This is what we're really going to cover today. Productivity goes from low to high. Soil pH changes. Biodiversity changes. So those are the main things. So today we want to cover the main changes that happen as we go through this this cycle of succession. Okay, so I copied the main things from the syllabus. It's all basically knowledge. There's not much there's nothing actually in applications as far as changes in succession goes. It might look a bit complicated, but I think we can cover this fairly quickly. So the syllabus says we need to cover changes in patterns of energy flow. Specifically, we look at gross and net productivity. It says we look at mineral cycling. I'll call that nutrient cycling. That's very straightforward. We'll just look at that in a second. We need to look at how gross productivity and net productivity change as we go through succession. Don't worry about this yet. We need to look at a very specific graph, which is the PR ratio. I'll explain that in a second. I'll read through that. And then we need to look at the effect of humans on succession. We've mentioned this already, but I'll do that in more detail. We'll look at the idea of plagioclimax as well. What happens when humans come along and interfere with natural succession. Okay, so pause that if you want to go through it. Otherwise, I'll move on. Basically, in this lesson, I want to show you two graphs. This is the first one. So before I do that, let's just talk again about gross GPP, gross primary productivity, and net primary productivity. To make this lesson simple, we'll only talk about plants, basically, so primary productivity. The gross primary productivity, you'll remember, it's got a complex unit. Let me just write it down here. Usually we'll talk in terms of biomass or kilograms. That's production, but because this is productivity, we talk about kilograms per meter squared of land, and because it's a rate of change over time, usually per year. That's the unit of primary productivity, whether it's gross or net. The gross primary productivity is the overall biomass produced per square meter per year. The net primary productivity is when you subtract the losses, in this case, just due to respiration. Because we're talking about plants, we don't take loss due to defecation into account because plants don't poo. Okay, so let's look at this graph. Let's look at the green one first of all. The green one is pretty obvious. We've already said that over time, biodiversity increases. Increases until it reaches a plateau. Until it reaches its maximum biodiversity, and that maximum biodiversity happens at the end of succession when you reach the climax community. So I'll just put that there. So the end of all this is the climax community. What we need to look at really is the difference between the gross primary productivity and the net primary productivity. So at the start of succession, let's say primary succession, you've got your pioneer species. Those are the very small plants or plant-like organisms, mosses, liverworts, lichens, those kind of things. They have a very small gross primary productivity because there's so few of them. The density is very low. But also, because they grow very efficiently, they're very efficient at using the nutrients that are available from the rocks. There's very little difference between, at the start of succession, between the gross primary productivity and the net primary productivity. They lose very little energy to respiration or very little biomass. So therefore, gross primary productivity and net primary productivity is very close together. As we move through succession and we get to kind of the secondary colonizers, the small trees and shrubs, you'll see they have a very high gross primary productivity. They're growing very, very fast. But also the difference between the gross primary productivity and the net primary productivity is quite high. There's a big difference between them because there is quite high net primary productivity. So therefore, they're growing quickly, but they're losing a lot of energy due to respiration. The growth rate is actually highest not when you reach the very slow growing trees like a forest or oak forest at the climax community. The growth rate is highest somewhere here in the middle when you've got these very fast growing trees and shrubs. Then, even though biodiversity is increasing, more niches are becoming available. You've got more different species. At this point, as you move towards the climax community, the gross primary productivity actually falls. The net primary productivity also falls. And at this point, at the climax community, you've got high gross primary productivity, but you've also got high net primary productivity. They're very close together. You're not really losing much energy due to respiration at this point. All right, fairly complicated to get your head around. Please go through it again if you don't think I've explained it very well, or ask me questions. I'll move on to the second graph now. The second graph, or the green line, basically shows you the same thing I've just showed you. It shows you the PR ratio. The PR ratio is basically the ratio of the gross primary productivity to the net primary productivity. P stands for production or productivity. I've also heard it referred to as the photosynthesis. R represents respiration, losses due to respiration. So therefore, this is basically the ratio of gross primary productivity to net primary productivity. And you see, as you move towards the climax community, or I've written here climax forest, basically the P to R ratio gets closer and closer to 1. This is a little bit confusing because at the start of succession, I already said with pioneer species, you're likely to have P and R fairly close together. So this is basically showing you secondary succession. As you move towards the climax community, the P to R ratio gets closer and closer to each other, and it gets closer and closer to 1. Basically, on the graph I showed you before, there's very little difference between gross primary productivity and net primary productivity. The red line, well, it basically shows you what happens if you're growing stuff in agriculture. Now, a farmer does not want to allow a forest to grow on their land. They want to basically be able to harvest, it might be monoculture, to harvest it at the highest growth rate so that yield is high. They don't want to wait until a community becomes established, or a climax community becomes established on their land. So a farmer will allow the crop to grow, and then at this point, harvest it, stop it, go back to the beginning again. Allow it to grow again, stop it, and harvest, and so on. Maybe you've got more than one harvest per year. But this, in red, I hope you've realised, at this point, this would be an example of a plagio climax, which is the activity of a human actually stopping succession at a point, and in this case allowing it to go back to the start again. So that's plagioclimax. Again, pause this and have a look at that graph if I've not explained it very well. Right. And then finally, I'd just like to finish off this this little video by going back to the definition of plagioclimax. Plagioclimax is an interruption in succession. Humans are usually the source of it. Sometimes humans can do it by accident or sometimes on purpose. I've given you an example of purposeful plagioclimax where a farmer harvests a crop. Obviously, the greatest plagioclimax is if the habitat is wiped out completely, for example, through deforestation. Other examples of purposeful or accidental plagioclimax might be harvesting, erosion by people walking over land, for example, on a footpath, accidental trampling, either by humans or animals, of plants in a community. Hunting is an example of plagioclimax. Clearing land completely, as I said already, or the introduction of animals that will graze the land. If you put sheep on a piece of land, the sheep will basically eat the plants available in such a way that they keep returning back to the start of the secondary community, which are basically grasses. They won't allow other species to become established. And obviously, if you've got grazing animals, you can't come close to coming towards a climax community. All right, so if I just return back to the syllabus. Number one, have a look at how you think gross net productivity, biodiversity and nutrient cycling happens over time. Obviously, maybe I didn't mention this very much in there. Nutrient or mineral recycling is going to be very high towards the end of succession when you get towards a climax community, because you've got all these niches established and you've got decomposers, detritivores, all those little niches with organisms that can recycle nutrients are established. So mineral or nutrient recycling is very high towards the climax community. Have a look at how the primary productivity, or the gross and net primary productivity, changes as you move from a pioneer community to a climax community. That's the first graph I showed you. Number three, please think carefully about how the second graph I showed you shows the change in the P to R ratio, or the production to respiration rate ratio, we could call it. When you get to a climax community, you get towards 1, where basically all of the production is offset by respiration, and the P to R ratio is 1. And then finally, make sure you understand plagioclimax and the effects of a human on a community, or the effects of humans on succession as it moves along. Okay, I've probably condensed that far too quickly, but we're going to go back through it over in the class as well. Go back through the graphs is the main thing, those 2 graphs, and make sure you understand them. Okay, take care, and I will speak to you soon.